Okay, again, I do apologize that this spilled into a second video. This topic is just kind of a complicated one to set up here. Okay, we left off on the other video where we had just made this 30, 60, and 90 right triangle. We had just talked through how the hypotenuse, actually in all of these triangles, is 1, because that's what the radius is, and that's the side we're always going to know on all of these triangles, that the hypotenuse is 1. And we had worked out that this short leg was 1/2, this long leg was square root of 3 over 2, and we put those together to get the coordinate for the 30-degree angle. And then we just had said, well, what if we took this blue triangle here and reflected it across the x-axis where this 30-degree point is? It would coincide with this 150-degree angle point here. But the sides, the legs of the triangle, are essentially the same length. The only minor adjustment is now, since we're on the negative side of the x-axis, we need to make that coordinate negative. So let's go ahead and just kind of write. We know in quadrant 1, that's where our x and y values are both positive. We know in quadrant 2, that is where the x coordinate's negative and the y is positive. They're both negative down here in quadrant 3. And then over here in quadrant 4, the x is back to positive, but now the y is negative. So if you could just picture taking now the blue triangle that we reflected into quadrant 2, but now we're going to flip it down into quadrant, I'm going to use a different color here, down into quadrant 3, it would then land right next to this point. Okay, so that 150-degree point is now right here. Now notice, every time I flip this triangle into a new quadrant, the lengths of these sides have not changed at all. So what you're going to find is whatever the original coordinates were that you got initially here, those values, this stays in the x-coordinate position. You make a minor adjustment by changing it into a negative. Okay, the y-coordinate stays in the y position. We don't need to change that at all. Okay, now when I come down here, again, I'm keeping square root of 3 over 2 as the x-coordinate, 1/2 as the y-coordinate, but we know that all the points in quadrant 3 are both negative, so I need to make both of them negative. Okay, finally, if I take the orange triangle and I flip it across the y-axis, I'm going to take those exact same coordinates. You can see that this 210-degree point right here is going to land right on top of this 330-degree point. I'm going to keep square root of 3 over 2 as my x-coordinate, 1/2 as my y-coordinate. In this quadrant, the x-coordinate stays positive. The y-coordinate is now negative. Okay, so let me just get this cleaned up a little bit. I'm going to get rid of some of this junk here in the middle, all these triangles that I had sketched there. Okay, so you can kind of see how we get one, if you just get 1 point in quadrant 1, see how as you reflect it into the other quadrant, it kind of helps you fill in all the other quadrants. Okay, since we just did a 30, 60, 90 triangle, I'm going to skip the 45 just for the moment. We'll come back to that in just a second. I want you to go up to the 60-degree point up here, and I want you to drop down a vertical leg here. Okay, now keep in mind, since 60 is out here, that means technically this angle in here to that triangle is 60 degrees. Okay, now remember the side we know. We know the hypotenuse is 1. Now the short leg is this horizontal leg. So if I'm going to go backwards and take the hypotenuse and divide the hypotenuse by 2, now the horizontal leg is 1/2, and the vertical leg, if I took my short leg times the square root of 3, I would get the vertical leg to be square root of 3 over 2. Okay, to get the coordinates, you follow the horizontal leg, that should be the 1/2, and then the vertical leg, that should be the square root of 3 over 2. Okay, now I just want you to picture, I'm not going to draw it now, but I want you to picture taking this triangle, if you reflected it over here into quadrant 2, see how the 60-degree angle would land directly on top of this 120-degree angle. That means that if I were to take the coordinates of this point at 60 degrees, I'm going to fill them right in here. The only minor adjustment I'm going to make is all the x-coordinates in quadrant 2 are negative. Okay, then if you were to take this point at 120 and imagine reflecting that point down into quadrant 3. Like if you were to fold your paper on the x-axis, this point would land down here. So I'm going to keep my x-coordinate as 1/2, my y-coordinate as square root of 3 over 2, but I need to make both of those coordinates negative because I'm in quadrant 3 here. Okay, and then lastly, if I take this point at 240 and reflect it over the y-axis into quadrant 4, 240 is going to coincide with 300 degrees. So again, keeping those values in the same order, but in this quadrant, the y value is negative, so I'm making that negative. Okay. Hopefully you guys can see where I'm getting these coordinates from. It would be really important that at some point you need to be able to fill all of these in, okay? Okay, so our last coordinates here, and we're going to talk about tangent another day here, is looking at the 45, 45, 90 triangle. Again, we only know that this hypotenuse is a length of 1. Okay, so I'm going to fill in, I know that's 1. If we were to look back at the previous page to this, we said that to get the leg of a 45, 45, 90 triangle, you have to take the hypotenuse and you have to divide it by the square root of 2. Now I'm going to write that just off to the side over here real small. Okay, I'm going to divide the hypotenuse by square root of 2, and I know that since I'm working in the unit circle, I'm not supposed to leave this radical symbol in the denominator. So I have to get rid of that radical symbol in the denominator the way that we started at the very beginning of this notes page by multiplying both the numerator and the denominator by square root of 2. That tells me that each of these two legs is square root of 2 over 2. Okay, so when I fill in the coordinates for 45 degrees, my x-coordinate is exactly the same number as the y-coordinate, at least for quadrant 1. Okay, when we reflect this 45-degree point over here into quadrant 2, it coincides with the 135. You're going to keep those obviously square root of 2 over 2 and square root of 2 over 2, but we're making the x-coordinate negative. Okay, I think you get the idea here now that as we reflect these down, we're just making minor sign adjustments only to make sure that it makes sense with what quadrant we're in, whether the x or the y should be positive or negative. Okay, so here we have almost the whole unit circle filled in, minus the tangent values, which we'll tackle those another day here. Okay, I want to show you now how you use the unit circle. Okay, so I'm going to go back to just kind of sketching this special right triangle that's at the 30-degree mark here. Okay, so here's my triangle. I know this angle in here is 30 degrees. I'm going to go ahead and label. I know the hypotenuse is 1. We said the short leg was 1/2. And then the longer leg was square root of 3 over 2, okay? Now, you're going to be asked questions like, and I'm just going to go ahead and scroll to the next page so you can see how these questions are asked. You're going to be asked questions such as, use the unit circle to find, when it says exact values, that means no decimals, and we definitely don't want any radicals in the denominator, okay? We'll find the exact values in simplified radical form. You are just going to pull your answers right off of the unit circle, okay? So now I will tell you that on the back of your worksheet tonight, there is a blank unit circle like this. I want you to try, and I know it's really hard the very first day, I want you to do the best you can without looking back at your notes. At least try this first, okay? And see if you can fill in all 16 of these angle measurements on your own using the pattern add 30, add 45, add 60, add 90. Okay, and then see if you can't, like you certainly should be able to fill in these 4 points without hopefully looking back at your notes, and do the best you can to see if you can fill in these other points here, okay, minus any of the tangent values. Okay, once you've given it your best effort, then kind of cross-reference, make any corrections by looking at the notes page, okay? Now, here's how this works. How do you answer these questions here using the unit circle? What you're going to do is if you look at this red triangle that I have kind of sketched out here, what you'll notice about cosine is if we were to do cosine for this, cosine would be the adjacent leg. Now, here's what you're going to notice about all of these triangles. The adjacent leg is always going to be the horizontal leg, okay? And here's what we know about the hypotenuse. The hypotenuse is always a 1. So if you're asked to do what's cosine of 30 degrees, and you're going to look at this triangle and you're going to say, well, the adjacent leg is the horizontal leg, square root of 3 over 2, and the hypotenuse is 1, what you're going to find is on all of these problems, you're just going to be taking, for cosine, the adjacent leg over 1. Well, this is kind of silly to write over 1. Really, cosine of 30 degrees is just going to be the square root of 3 over 2. Okay? If you were asked to do sine of, say, 30 degrees, well, now sine is going to be the opposite leg, and the opposite leg in all of these triangles will always be the vertical leg. Okay? So you're going to take the opposite leg, 1/2, over the hypotenuse, which is 1. Kind of silly to put that over 1. So sine of 30 degrees is 1/2. Do you notice that for cosine, it ended up just being the x-coordinate of the point, and for sine, it ended up just being the y-coordinate of the point, okay? So I'd like for you to circle, highlight this right here, and put like an x above cosine and a y above sine, okay? So here's how this is going to work. Let's look at this first one. It asks you for sine of 900 degrees. So what you need to do initially is you need to figure out where would 900 degrees fall on your unit circle. Okay, so what you're going to do is you're going to subtract 360, and you're going to keep subtracting 360 until it lands at a number that's somewhere between 0 and 360, so you know where you're supposed to look. Okay, so this is asking for sine of 180 degrees. You're going to go to 180 degrees on the unit circle. Okay, so you're going to go right here to this point, and you're going to say to yourself, sine is always the y-coordinate of the point. So whatever the y-coordinate is at 180, that is what you are writing down as your answer. Done. Okay, let's look at B. This is cosine of negative 420. Well, since it's negative 420, let's add 360 to that. I think you still get negative 60, so let's add 360 to that again. Just keep adding 360 until it lands at a number that you're going to see on the unit circle, 300 degrees. Now, this is a cosine problem, 300 degrees. So you're going to go to your unit circle at 300 degrees. Okay, we're right here. Remember, cosine is the x-coordinate. So at 300 degrees, you're going to grab the x-coordinate, which is 1/2, and that is what you're going to write down as your answer for cosine of negative 420. It's the same thing as cosine of 300. Okay, let's try one that's not sine and not cosine, but one that is the reciprocal, okay? And so when you see, oh, this is a secant problem, you need to say to yourself, oh, that's actually the reciprocal of cosine, okay? Now, negative 60 is not an angle in the triangle that you can see right off the bat, so let's go ahead and add 360 degrees to that so we know where we're looking at the circle. If you add 360 degrees to negative 60, that puts you at 300 degrees, okay? So here's what you want to do. You want to go to the unit circle at 300 degrees, and you want to keep in mind our answer has to be the reciprocal of cosine. So at 300 degrees, where are we at? Right here. Cosine would be the x-coordinate of 1/2, but we're asked for secant. So instead of writing down 1/2, we're going to do the reciprocal of that and write 2 over 1. Okay, all right, let's try E. We're skipping the tangent and cotangents. In fact, on your homework tonight, you're not to do any of the tangent or cotangent problems on the worksheet. This is a cosecant problem. You first need to ask yourself, okay, cosecant is the reciprocal of what? It's the reciprocal of sine, okay? Now, 315 is something already I can see in the triangle. So I want to go, or in the circle, sorry. I want to go to 315 degrees. I'm looking for the sine value at 315 degrees. Now remember, we said sine up here is the y-coordinate. So you're going to go to 315. You're going to grab the y-coordinate, which is negative square root of 3 over 2. Okay, but this problem was asking for cosine. So instead of me writing down negative square root of 2 over 2, I'm going to flip it, so I'm doing the reciprocal. And I don't want to circle that as my answer, because I want to get rid of the square root symbol in the bottom. So I'm going to multiply across the top, multiply across the bottom, cancel those 2's. This is the answer I'm going to write down. Okay, I'm going to go ahead and jot down just what the answers are for G. Okay, and you can kind of cross-reference these here. Oops, that's 240. Okay, that would end up being that.